So 5.4 is about factoring. So whenever you're factoring, you always need to check the greatest common factor. Okay, so I always check to see, can I divide all of the terms by a number or a variable or some number variable combination. Then I check to see if there's two terms. In that case, I do difference of squares. So difference of squares looks like a squared minus b squared. And that factors out into a minus b times a plus b, which I guess is I have right here. Then if there's three terms, I try to see if it's a perfect square trinomial if a doesn't equal 1. So in this case, a equals 1. This case, a equals 1. This case, a doesn't equal 1. So if a doesn't equal 1, I try to have a perfect square trinomial. So a perfect square trinomial looks like this. If you have a plus b squared, that's going to be equal to a squared plus 2ab plus b squared. And then if you have a minus b squared, that's going to be the exact same thing, except for it's going to be a squared minus 2ab plus b squared. So I'm kind of looking at, can I take the square root of the ends of the outsides, and then I check by foiling to see if what I think is correct with my factor will foil out to be the original problem. So for number 1, again, following this flow chart, I'm going to always check the greatest common factor. So in this case, I can take a w out, or a y. So if I divide 7y squared divided by y, I get 7y. And if I divide 4y divided by y, I get 4. And I keep the symbols the same. This was a subtraction, this is a subtraction. So this is my answer. I can't go any further with that. Okay, 2 does not have a greatest common factor, so it has 3 terms, and a equals 1. So I'm going to do factors of c. So think about factoring ax squared plus bx plus c. So I'm going to find factors of c that add up to b. So two numbers that when I multiply I get negative 99, and I add and get 2. So these factors have to be close together. So you could try 1 and 99, but those are far apart. And also I think of 3 and 33, but the answer is going to be 9 and 11. So this is going to factor out into c minus 11, c plus 9. Now the reason it goes negative 11 and positive 9 is because this is a negative 2. So negative 11 plus 9 adds up to negative 2. Okay, 3 does not have a greatest common factor. So it's 2 terms, so I'm going to do difference of squares. So in order to get a 9, I have to think of 2 things that multiply that are the same that give me 9. So in that case it's 3. Basically I'm taking the square root of 9. And I'm taking the square root of 64p squared. So the square root of 64 is 8. And then the square root of p squared is p. And these symbols need to be opposite. I just wrote a plus, but meant to write a negative. So here's my answer. Because I could check it and FOIL it out. It would be 9 minus 24p plus 24p minus 64p squared. So these middle terms cancel out. Okay, number 4, I'm doing there's no greatest common factor. So, and the a is not equal to 1. So I'm going to do factors of 25 that add up to negative 10. So 2 numbers that multiply to be 25 and add to be negative 10. So I write n and n because that's how I get n squared. So factors of 25 are 1 and 25 and 5 and 5. Okay, it has to be 5 times 5 because actually it's got to be negative 5 and negative 5 because negative 5 plus negative 5 is negative 10 and negative 5 times negative 5 is 25. Okay, 5, I can't divide everything through. So what I'm going to check is I'm going to check for a perfect square trinomial, because I'm noticing that I can take the square root of the first term and the last term. So I'm going to check. The square root of 4y squared is 2y. The square root of 9 is 3. Now, if this is a positive in a perfect square trinomial formula, these two will be positives. So I need to check to see if it FOILs out. So 4y squared plus 6y plus 6y plus 9. That doesn't give me 6y, that gives me 12y. So actually this one does not factor. We're going to try a different method in the next lesson, but it actually doesn't factor by that method either. Okay, number 6. I check for the greatest common factor. It does not have a greatest common factor. So then I do check for perfect squared, because I can take the square root of this and this. So this is going to be the square root of 144x squared is 12x. And the square root of 25 is 5. And since this is a negative and this is a positive, these both need to be negative. So now I'm going to check to see, does this FOIL out? So 12x times 12x is 144x squared. Outside, negative 5 times 12x is negative 60x. Inside is negative 5 times 12, so that's negative 60x. And then last is going to be plus 25. So when I combine these, I get negative 120, so this does work. You can write your answer like this, or you can write your answer as 12x minus 5 squared. Either one. Okay, number 7, I'm noticing that it does have a greatest common factor. I can actually divide both of these terms by a 3. Then I can go further because this is difference of squares. So this is going to be 3 and then 2 sets of parentheses. So in order to get x squared minus 9, my x has to be, I have to have an xx. And then the square root of 9 is 3, so it's 3 and 3. And to get a negative, one has to be a positive and the other one has to be a negative. Okay, number 8. No greatest common factor. So this number out front is 1. So I'm going to find factors of negative 22 that add up to be negative 9. So the only factors of 22 are 1 and 22 and 11 and 2. So since this is negative 22, one of them needs to be negative and one of them needs to be positive. So this, I'm going to write x and x. I know that for sure to get x squared. And then I'm going to have my negative 11 positive 2. Because the negative 11 plus 2 adds up to negative 9. And 2 times negative 11 is negative 22. Okay, number 9. Again, no greatest common factor. So I do 2 sets of parentheses, x, x. So factors of negative 30, so I know one of them has to be positive, one has to be negative, that add up to 1. So if they add up to 1, factors of 30 are 1 and 30, 2 and 15, 3 and 10, 5 and 6. It's got to be 5 and 6 because these are 1 unit apart. So it needs to be a positive 6 and a negative 5 because negative 5 plus 6 adds up to 1. And then number 10, I want to find the greatest common factor. So I can divide both of these terms. They both have a y in them, and I can divide both of them by 2. So the greatest common factor is going to be 2y. So if you divide 6y squared divided by 2y, you're going to have 3y. And if I divide 8y by 2y, I'm going to have 4. So whenever you're factoring, you should look to see if can each one of these factors could be factored any further. In this case, you cannot. So this is the answer. And then the last one, again, you have a number that's not a 1 out front. it's a 9, so I'm going to try the perfect square trinomial method, which means I'm going to take the square root of the first term, which is 3y, and put that in both spots, and take the square root of 16, which is 4, and put that in both spots. And the symbols must be, in order for this to be a negative and this is a positive, they both need to be negative, because negative times a negative is a positive, and a negative plus a negative is a negative. So now you need to check it. So check it by foiling. So 3y times 3y is 9y squared minus 12y minus 12y and then plus 16. So this will turn into negative 24y. So this is the answer.